Problem 1, a statistics class of 20 students takes the final exam. The scores were as follows. And for the first part, we need to find the mean, the median, and the mode. These are what we call the measures of central tendency. So take a moment and enter this data into your calculator and find the mean, median, and mode. So here I have 20 pieces of data, and here the mean, 77.35, the median, 84.5, and remember the calculator doesn't directly tell you the mode. I think the best way to go about finding the mode is to sort the data in order. So here I press the Stat button. I'm going to go to option 2, which is sort in ascending order. And then I'll press, for me, second, and then the number 1, because I used list 1 for my data. And what my calculator is going to then do is show me the data, show me the list in order. So when I go back to Stat and Edit and look for list 1, I can see that it looks like there are more 85s than any other value. So here our mode is going to be 85. So now for number 2, it's asking you to consider the mean and the median. And if both of the aforementioned statistics are the measure of center, because in statistics, the mean, the median, and the mode are considered the 3 measures of central tendency, the measures of the center of the data. And each has strengths and weaknesses. So it says if both of these statistics are the center, why is there such a discrepancy? Here the mean is 77.35, the median is 84.5. And when data is what they consider to be normally distributed, when you have large sets of data, they could be classified as normally distributed, which basically would mean the mean, the median, and the mode would all be about the same value. And here there's such a discrepancy. And the reason why we have that is because we have 2 data values, the 0 and the 11, which don't seem to fit in to the rest of the data. Here we're talking about grades on a statistics class and their final exam. And all the grades are in the 80s and the 90s. I see a 70 there. But the 0 and the 11 are kind of throwing those values off. It's making the mean and the median much, much different. So why is there discrepancy? Because of the 0 and the 11 data values. Now it says which statistic, the mean and the median, is the better indicator of how majority of the students will perform on the test. Well, here the mean is in the upper 70s. Here the median is in the mid 80s. If you had to say which of the 2 better describes the data, here I would say the median. Because if you look at your data values, it looks like a majority of them are all in the 80s. So here we're going to say the median because a majority of the grades are in the 80s. If you said, okay, I gave an exam and the average is 77.35, most students would think, okay, most of the students would be in the upper 70s. But no, here the median is the better indicator of how the students did. Now what we need to do is we need to calculate the 10% trimmed mean for the data. So what we're going to do is we're going to figure out what 10% of the data values is. Here we were given 20 numbers. So here we're going to do 10% of 20, or 0.10 times 20, or when you take 10%, you just move the decimal point once to the left. So here it's going to be 2. So to find the 10% trimmed means, what we're going to do is we're going to drop the 2 highest and two lowest test scores, and then re-average. So here we're going to drop the two highest and the two lowest test scores because 10% of 20 is 2. So here I have my list of 20 data values, and here we're going to drop the 0 and the 11, and here we're going to drop the 94 and the 98, and we're going to average the middle 16. So here I'm now left with 16 pieces of data, and here the average, the 10% trimmed mean, is going to be 84. And now the question is saying, consider your values for the mean. So here the mean was 77.35, and the trimmed mean, 84. Which statistic is the better indicator of how a majority of the students will perform on the test? And explain. Well, here, just like before when we said the median was better than the mean because most of the grades were in the 80s and the median was in the 80s, here too we're going to say the 10% trimmed means is better because of the same reason, because a majority of the students scored in the 20s. I apologize, a majority of the students scored in the 80s. Problem 5, Joey's first 14 quiz grades were given, and here you have to calculate both the mean and the median for the data. So take a moment, pause the video, enter your data into your calculator, and figure out both the mean and the median for Joey. So here we have the mean is 85, and the median is also 85. And I always check to see if I have the correct number of numbers. In this case, n is 14, and that matches. Now the question says, suppose Joey has an unexcused absence for the 15th quiz, and he receives a score of 0. Determine his final quiz average, and then what property of the mean does this situation illustrate? So what I'm going to do is I'm just going to enter in now as a 15th grade of 0 and recalculate the mean, recalculate his quiz average. So now I have 15 test grades. I entered in as the 15th number in the list 0, and here his average, the X bar, is 79.3. Now what property of the mean does this illustrate? Well, basically what happens is the mean is heavily influenced by what we call in math outliers, data values that lie outside of the norm. Here, most of the quiz grades were 80s, I see a couple 70s, I see a couple 90s. By entering in this 0, that's a data value that's very distant from all the other data values. That's what we call in statistics an outlier. And that's the disadvantage of using the average or the mean as an indicator of your data. If you have values that are so far different from the rest, the mean is heavily influenced. The median, the middle value, not so much. Problem 6. Suppose a Major League Baseball team's mean yearly salary is $1.2 million and the team has 25 players on its active roster. What is the team's annual payroll for the players? So here we know the mean, the average salary is 1.2 million. And there's 25 players on the roster. Now, we do not know what each of the 25 players makes, but when you average them, it's going to be 1.2 million. So what I'm going to do is I'm just going to pretend that all 25 players made 1.2 million. Because if all 25 players made 1.2 million, the average would be 1.2. What you can always do when you know the average, to get the sum of the data values, because that's what letter A is asking for, what is the team's annual payroll? To get the sum, what you can always do is you can always take the mean and multiply it by the number of data values. That's what I'm going to do. Here I'm going to say the average is 1.2. I'm going to pretend each of the 25 players makes 1.2 million. So I'm basically going to be adding up 1.2 million 25 times. I'm going to take the mean and multiply it by the number of data values. And that's going to give me the sum of the data. So here I took the average, the 1.2 million, multiplied it by n, the number of data values. So here I had 30. And since the 1.2 stands for million, here the sum of the player's salary is 30 million. Letter B, if you only knew the median salary, would you be able to answer the question, why or why not? Median is the middle number of the data. So let's say we had 3 players on the team and not 25 players. Well, take a look at these two hypothetical teams. Let's say Team A has players that made 1 million, 2 million, and 25 million. Let's say all these data values are in millions. So we're going to say Team A has 3 players, and those are their salaries. Team B also has 3 players, and let's say their salaries are 1 million, 2 million, and 3 million. Now, the median for both teams, the middle data value, well, since I'm pretending that there's 3 players, here the median value, if you put the data values in order, is the middle number. It's that second number. So both teams' medians are 2 million. Can you know the sum of the salaries based on just knowing this? No, because look at Team A. Team A, their sum is 1 plus 2 plus 25, or 28 million. Team B, their sum is 1 plus 2 plus 3, or 6 million. So if they said, okay, you have 3 players and the median is 2 million, there's no way of predicting what the sum is. So the average, yes, if you know the mean, you can determine the sum by using this formula. But if you know the median, you clearly can't, because here's 2 teams. Both teams have the same median, but the sum of the salaries is vastly different. Problem 7. Last year, a small accounting firm paid each of its 5 clerks $22,000. So 5 clerks each made $22,000. 2 junior accountants made $50,000 each, and the firm's owner $270,000. What is the mean paid at this firm? What I'm going to do is I'm going to use the frequency distribution feature of the calculator to go about answering this question. I'm going to enter the data into one list and the frequencies in another. So here I have the 5 clerks making $22,000 each, the 2 junior accountants making $50,000 each, and I have the firm's owner, so there's 1, making $270,000. So So now I'm going to use the frequency distribution feature of the calculator. I went to Stat and Calculate, and then the one variable Stat. And for my list, I'm going to use L1, which is second, and then the number 1, because that is the list that contains the data. And for my frequency list, which normally is kept blank, here I'm going to use list 2, because those are the frequencies, how many times each number occurs. I'm going to calculate these one variable statistics based on this frequency distribution feature. So here it turns out that the mean salary paid is $60,000 and the median salary paid is $22,000. And it says, write a sentence to describe how an unethical recruiter could use statistics to mislead prospective employees. Well, what they could do is say this. They could say, come work for our company, because that's what a recruiter is. They want someone to come work to their company. They're recruiting people to come work for them. They could say, come work for our company. They could say, the average salary at our company is $60,000, which is mathematically true. The average, the mean, is $60,000. But if you look at the employees' salaries, 5 clerks make $22,000, so that's less than the mean. 2 junior accountants make $50,000 each. That again is less than the mean. There's only one person at this company, and that's the firm's owner, that makes more than the average. So although mathematically it's true to say, come work for us, the average salary at our company is $60,000, what an ethical recruiter would do is say, come work for us, but here's the truth, the median salary is $22,000. So that's how you can use data to mislead. Sometimes knowing data values is not the best indication of what's going on, because there's the average, but that's not really a good indicator of what's going on. Remember, the average is heavily influenced by outliers. This $270,000 employee, the owner, is throwing off the data values. Problem 8, in 1997, the mean and median incomes of the top 1% of Americans were $330,000 and $675,000. Which of these numbers is the mean and which of these numbers is the median, and explain your reasoning. Well, they're not telling you which is which. You have 330,000 and you have 675,000. But here's the key to the question. They're dealing with the top 1% of American salaries. So you're talking about the rich of the rich. And if you think about the top American salaries, right now, you're dealing with owners of companies, websites. The top 2 or 3 salaries are in the billions of dollars. But in terms of the top 1%, there's still lots of people making millions of dollars. So basically what this question is saying is, which is going to be which? Well, the people making billions of dollars, they're in the top 1%. The millions of dollars, they're in the 1%, but there's a few billionaires. What that's doing is it's going to make the average be much, much higher than the median. Here, I'm going to say that the average is 675,000 and the median was 330,000, because the average is much more subjective and influenced by outliers. Here, there's going to be a few very high outliers that are going to throw the average much, much higher. Just like in the last question that we did, the average was much, much higher than the median because of that one owner making 270,000. So that one very high outlier made the average jump up much more than the median. And I claim in this one, when you're dealing with the top 1% of salaries, there's going to be a few very, very high outliers in that top 1% that are going to throw the average up. So here's our answer. The average would be 675,000, the median 330,000.